So the objectives of this lecture is just to look at policies for which the benefit amount varies over time. So that would include conventional and accumulating with profits contracts. Then also we will then calculate the expected present value of benefits when they increase by a constant amount or a percentage each year. So this will basically then give you the skill for you to be able to calculate premiums and reserves for with profit policies. So I'm going to start by introducing you to payments varying at a constant compound rate. So we first consider whole life assurance policy, which is issued to a life aged X, and where the benefit is payable at the end of year of death. And this is increased by a bonus, which would denote as B, which would be 1 plus B to the power K. If death occurs in the year of age X plus K and X plus K plus 1. So K will take values from 0, 1 up to infinity. So in terms of the expected present value of these benefits, you'll find that the formula would be this one, which is the summation of K from 0 up to infinity, 1 plus B to the power K, VK plus 1, and QX with a K at where the probability of a life survives for the first K years and dies within the next year. So you see that this is just similar to the expected present value of a whole life assurance, where the sum assured isn't being increased by a constant compound rate. The only difference is the 1 plus B to the power K here. So if this is simplified, you see that this would then equal to 1 over 1 plus B with the assurance function X, where J will be calculated as the interest rate, where I put 1 plus I over 1 plus B minus 1. So you see that for other assurances, you can derive the value using this similar approach. And you can also be able to calculate the value of compound decreasing benefits when B is negative. So for example, here we are told that calculate the expected present value of a whole life assurance taken out by a life aged 50, where the basic sum assured is £100,000 and the sum assured increases by 1.923% at the start of each year, excluding the first year. The benefits are payable at the end of year of death. So assume an M92 ultimate mortality and a 6% interest rate. So you find that if we use this formula at the beginning to write out the expected present value of this benefits, you see that it will then be 100,000. You take it out because it's a constant, where you say in the bracket it would be now VQ50 plus 1.01923 V squared Q50 with the dash here 1, and so on and so on. So you find that the bonus rate 1.92% only applies at the second year, not the first year, as the question says here. So for you to then solve this, you need to take out the increase where the sum assured is increasing. You take it out to just ensure that the increase of the sum assured has the same power as the V in the equation. So you find if you take it out, it will now be 100,000 over the 1.0192 increase. Then in the brackets now, it would be the increase over the V function, Q50. And you see that the increase in the V function have now the same power. So you see that this function in the brackets now then simplifies to A50. So remember where we said that for an assurance function that is calculated this way, J will be equal to 1 plus I over 1 plus B minus 1. So here you see that the assurance function will be calculated at 4% if you evaluate J from the formula that I've shown you above. So you see that A50, you can easily look it up from the tables. So this would be A50 times 100,000 divided by the sum assured increase. So you find that this then solves to 32,286. So moving on to the expected present value for survival benefits that also vary in a compound way. You find for an immediate annuity payable annually in arrear with the benefit payable on survival to age X plus K, where K will take values from 1 to up to infinity. The expected present value of this annuity would be the summation of K equal to 1 up to infinity, where P, K, X, then in brackets it would be 1 plus CK, which would be the compound increase that would be applied to the annuity, then VK. So this would be basically equal to the annuity payable in arrears for a person aged X evaluated at the J interest rate, where J is just similar, would be 1 plus I over 1 plus C minus 1. So you see that this is just also somehow similar to the annuity payable in arrear, where there is no, the only difference is the 1 plus CK here. So you'll find that this approach, you can also use it for compound decreasing annuities by using a negative value for C. So in terms of payments changing by a constant monetary amount, we'll start by looking at whole life assurance. So we consider a life aged X where the benefit payable at the end of year of death is K plus 1. If death occurs in the year of age X plus K and X plus K plus 1, where K will be equal to 0, 1 up to infinity. So you find that the expected present value of this assurance benefit would be the sum of K from 0 up to infinity, where in brackets it would be K plus 1, V K plus to the power of VK plus 1, and this QX function. So this is just denoted by an actuarial symbol, capital letter I and A for a life-aged X. So you find that in your actuarial tables, the values for this actuarial function, they are given. And just looking up this function in the table is the quickest way of evaluating this function. So for a term assurance, an increase in temporary assurance can also be evaluated using this formula, which would be an increasing term assurance function for a life-aged X with a duration of N equal to the whole life function, an increasing whole life function X, and subtracting it with the discount factor being multiplied by these assurance functions in the brackets. So you should be in a position to know these formulas and also be able to apply them when you are asked a particular question in the exam. So I'll move on to an example. A man aged exactly 40 buys a special 25-year endowment policy that pays 30,000 on maturity. If the policyholder dies before age 65, then all premiums paid so far are returned without interest at the end of the year of death. Level premiums are payable annually in advance for 25 years or until earlier death. Calculate the annual premium assuming a M92 select mortality and 4% interest. Ignore expenses. So you see that when you're asked to calculate your premium, what you should think of is the equivalence premium, the equivalence principle, where we said earlier in our lecture that we had last week, Thursday, where you should equate the expected present value of benefits to the expected present value of premiums. So from here, you can see that the expected present value of premiums will be denoted by, the annual premium would denoted by P, and the expected present value of premiums would be P, the annuity due for a life-aged select 40 with a duration of 25 years. And this annuity function, you can easily take it from the mortality tables because the mortality tables give you for an annuity, a temporary annuity like this, for up to ages 65 and age 60. So this, you'll see that you can easily take it from your tables, and the result would be 15.887p. So in terms of the maturity, the expected present value of the maturity benefit, you see that the maturity benefit from the question here, they're saying that it's a special endowment policy that pays 30,000 on maturity. So you find that you just say 30,000 times the discount factor, which we discussed about in our last lecture. So this would be 30,000 times D65 over D40 select. So you find that the expected present value of the maturity benefit would be 10,000, 073.81. So in terms of the expected present value of the death benefit, you see that the death benefit would be equal to, because here they're saying that if the policy holder dies before age 65, then all premiums paid so far are retained without interest at the end of the year of death. So you see that this would now be the increasing function will now be used here, because each premium that would be paid in each year, it would be retained. So you need to calculate the expected present value of the benefits of the death benefit, allowing for the premiums. So you find that the appropriate function to use here is the increasing and assurance function for an endowment, for a term assurance. Sorry about that. For a select life aged 40 with a duration of 25. So you see that solving this term assurance function here, the increasing one, you see that we need to use this formula that I've discussed earlier. And you find that by just substituting the values in the formula, IA select life 40, D65, D40, enter AIA 65 plus 25A65. All these values, you can easily take them from the tables, and then you evaluate it, and you get your 0.87615p. So I think people might be asking why this assurance function will be used, because the question is saying that all premiums paid so far will be retained without interest at the end of the year of death. So you notice that this is an increasing function which pays a sum assured 1 at time 1. At time 2, it pays a sum assured of 2. At time 3, a sum assured of 3, and so on and so on. So this assurance function is appropriate because it is increasing. And if we multiply by P, you'll find that at time 1, you pay P. At time 2, you pay 2P. At time 3, you pay 3P, and so on and so on and so on. So that's why this assurance function is appropriate. So once you've gotten, we've evaluated the expected present value of the death benefit as well as the maturity benefit, you then add the two and equate them to the expected present value of premiums. Then you solve for P. So P then is equal to 671 and 10 cents. So before I move on, I'm going to ask if there are any questions before I proceed. You can go ahead, Kay.
So I've got a question concerning the use, the appropriate use of commutation functions. For example, we applied some commutation functions D65 over D40 select there, right? Do we, is it always the case that we get the same answer as V25 times 25 P40 select? Because there are a lot of formulas that involve the use of these commutation functions, but most of the time I've tried to utilize them, they don't yield the desired answer.
Okay, thank you for that question. So what I can answer you in terms of use of the D functions, you'll see that in your tables, the D functions only apply for the 4% tables, And for the 6% tables, you have to calculate them using first principles. Like you have said that sometimes when you use the first principle approach and you equate it to the D values, you find that they are not equivalent. This is possibly just a rounding error, a rounding problem, where some of the values will be rounded and now you want to calculate them.
Okay, noted. Thank you very much.
Okay.
Yes,
So
ma'am.
if Noel, Knoxwell.
Nox. Yeah. Ma'am, I have a question.
Mm-hmm.
Are we going to do all the chapters in this course, or we have the main one?
I'm going to
Please, ma'am,
try.
because
Okay. Yes, you can go ahead,
yeah.
Knoxwell.
Yes, because I was thinking because of time, we only left with I think one week and a half somewhere there, and we need to cope up with this information. Some of things are new to us. We're not like others that have been doing like CM and all this stuff. So these things are new to us. So we was asking you if you are willingly and humbly and politely to just give us the topics that are going to come, and again some type of questions that are going to come, so that we may do other stuff in our party time, so that we can read for them. Maybe if you go to the companies, but only for the exam, you can actually give us what is going to come. It is actually humbly from our face to ask for that.
Okay. Okay.
Okay.
Who wants to? Hello. Okay. I was just getting feedback. Okay. Thank you, Knoxville. Definitely the exam will not consist of every single thing that I'm going to teach you. But I think in terms of just giving you maybe a brief what would be expected to really come up in the exam, you'd find that issues to do with net and gross premiums, pricing and reserving, those are some of the key topics, and also some of the earlier topics that we did last week, and then some joint life uh, topics, just a question on that, and also questions on profit testing. So it will just contain, but you find that with this course, some of the things you need to be familiar with in terms of the notation and everything for you to be able to apply a question in the exam. But in terms of having everything that we've covered in the exam, I can confirm that that would not be the case. I don't know if I've answered you well.
Yes, you've answered me well, ma'am.
Okay, so
And
just concentrate on the examples that I'm giving you,
yes,
and the questions that I'm also discussing in the lectures, and some of the questions that I'll also give you in your spare time to answer. That would be, I can just say that would be the reflection of your exam.
okay. Thank you,
Yes.
ma'am. God bless you.
Okay. So if there are no further questions, can I move on to the endowment assurance notations? I see there are no hands up. I'll proceed. So you see, for an endowment assurance that increases with a term of n years, can also be defined in a similar way. So you see that, for example, a payment of K paid at the end of year of death of a life X, if the life dies in policy year X, K, where K is less than A N, or a payment of N if X is still alive at the end of the term. So this expected present value of this can be evaluated using the functions that I've introduced to you. So you see that this is similar to an endowment assurance where there are no increasing elements, where you sum the term assurance component with the pure endowment component. The only difference here is that we have the increasing functions, and the pure endowment function we would have to multiply by n, because the last payment would have been increasing within the term, so you would have to multiply by n. So this function, again, we just have to know how to apply it for the endowment assurance. Then for the decreasing term assurance, it can also be defined in a similar way. So, for example, suppose the benefit is N in the first year, and then increases by 1 per subsequent year. So you find that the expected present value can be evaluated using the formula below. So you find that that would be N plus 1, and the term assurance function that is not increasing minus the increasing term assurance function. So this you also just need to know how to apply it when you're asked a particular question. So in terms of increasing assurance is payable immediately on death, you'll find that this is just similar to what we also did in our lecture last week, where you see that the whole life assurance function that is payable immediately on death can be approximated by 1 plus I to the power half times the whole life assurance function that is payable at the end of year of death, because we are bringing it forward. So you find that this is just similar to what we've just discussed. So the formulae, you see that this can be adjusted in a similar way to allow for immediate payment of the benefit on death for the term assurance, endowment, and decreasing term assurance. So I'm just going to give you an example in terms of how we calculate these. For example, let's say you are asked to calculate the value of an increasing endowment function where the life is aged 50 with a term of 10 years, assuming an M92 ultimate mortality with 4% per annum interest. You see that to evaluate this, we use this formula here that I've discussed. So it will be just basically the increasing term assurance function plus the pure endowment function. So now to solve for these assurance functions, you see that on surviving, the person would receive an amount of 10. That's why we are putting 10 here, as I said that in an earlier section. So you find the acceleration, the accelerated part of this assurance function will only apply to the death benefit. So you see that this is also a similar approach to what we also did earlier for assurance functions where the benefit wasn't varying in any way. So the acceleration of the payment would be only affecting the term assurance part. So you find that this would be then equal to 1 plus I to the power half times the increasing term assurance function plus 10 times the pure endowment function. So this is just, you find that this is just a discounting factor. So you use the D's because it's 4% interest. You can easily look them up in the tables. And you see this function here. You can easily evaluate it. Using the equation that I've shown you. Yeah, using this equation. So you need to apply this equation to this one here. So you see that this then solves to this, and you're now just looking up the values in the tables, and then you get your answer, which would be 6.673. So for a whole life annuity payable annually in arrears, so you find that the annuity will be increasing by a constant amount each year. So you find that the expected present value of this benefit would be K equal to 1, summing all this up to infinity, and K times V to the power K and KPX. So you find that this is just denoted by the actuarial symbol, capital letter I, small letter A, X. So these values are tabulated in the tables. So you'll be just looking them up. You find the annuity payable annually in advance. You just put the 2 dots on top of the A. So these ones are in the tables, the annuity dues. So you find that for the temporary annuities, you evaluate using a similar formula where you say A due X minus the discounting factor, multiplying everything in the brackets. So what you just need to do is just apply this formula whenever you're given an assurance function, like an annuity function that requires this to evaluate this. So for a decreasing temporary annuity with a term of n years, this can also be defined in a similar way. So you find that the expected present value of this, you see that it would be A plus 1, n plus 1 times the temporary annuity due for a life-aged X with a duration of n, and just subtracting with the increase in annuity due. So these are just formulas that you just need to know for you to apply whenever you're just given a question that requires you to evaluate an annuity like this. So you see that for annuities that are payable continuously, the expected present value of this, you find that the approximate calculation would be the increasing annuity payable continuously for a life-aged X. You can just approximate it by subtracting 1/2 the annuity due from the increasing annuity due. So this is just a formula you just need to learn to apply. So you see that the formula for these temporary annuities, you can easily adjust them to just allow for continuous annuity payments. So an example here is if you want to calculate the value for an annuity that is payable continuously, that is increasing, assuming that X is a life-aged X is subject to a constant force of mortality of 0.02 per annum, and the delta is 0.04 per annum. The interest that would be payable continuously. So you see that in the solution, if you want to express this in an integral format, so this annuity that is increasing and is payable continuously is the expected present value of a whole life annuity payable continuously to a life aged exactly X. So the rate of payment would be 1 per annum. And then in the first year, then in the second year it will be 2, and in the third year it will be 3. So it will be increasing by 1 each year, so on. So when you now write the integral expression of this, you see that this would be Vt ptx dt from 0 to 1. Then you sum it, you add on v2 2v to the power t tpx dt, and it's from 1 to 2 because it's only applying in that second year. So you see that this then goes on continuously. So since we're told here that we are assuming a constant force of mortality, we now need to use the result that we discussed in our earlier lectures, the result where if mu is constant, this would result to TPX being equal to e to the power minus mu t. So since we also know from your financial mathematics that V is equal to e to the power minus delta minus sigma, which is equal to e to the power 0.04. So if you now substitute all these values in the equation above, you see that you get this result. And then when you want to now solve the integral part, you then take out the constant, and the constant it would be 1 over 0.06. And then you now solve the integral parts in the brackets, and you see that this would be continuous. And once you've solved this, you see that it then simplifies to this here. So you see that once you've done this and you now grouping like terms and simplifying, it will now simplify to 1 over 0.06, then brackets now be 1 plus e to the power minus 0.6 plus e to the power minus 0.6 times 2, and so on up to infinity. So for you to be able to solve this expression, you need to recall the formula that applies to a sum to infinity of a geometric series, which is a divided by 1 minus r, where a is the first term in the series and r is the common ratio. So once you've done that, you see that this then just simplifies to 286.19. So I will end here and allow for any questions before I proceed.
No questions from this end.
Okay, so I can safely proceed to the other bit. So I'll be sharing the notes after the lecture, and also some practice questions at the end for you to attend. So I'm going to move on to net premiums and reserving for variable benefit contracts. So we're just going to recall formula that we discussed earlier, where you would say the expected present value of benefit is equal to the expected present value of premiums. So we're going to just look at another example. For you to just appreciate how to calculate these. So the question then says, calculate the annual premium that should be paid annually in advance by a 40-year-old policyholder for a 20-year endowment assurance with a starting sum assured of 40,000, and where death benefits are payable immediately on death. The sum assured will increase at a rate of 1.92 per annum compound at the end of each policy year. Assume an interest rate of 6% per annum and a M92 ultimate mortality. So from this, you see that just a hint, whenever you see that the increase is 1.92%, you know that the assumed interest rate would be 6%. So when you're evaluating the assurance functions that would be affected, you know that this would be evaluated at 4%. So firstly, you need to calculate the expected present value of the benefits. And you see that we've just taken out 40,000 because it's a constant, and that's the amount that is payable either when a person dies or when they survive. So we start with the term assurance function and then add the pure endowment function here. So you see that this is just the discount factor. And so once so you find that for the term assurance function, that one needs to be expanded a bit for you to be able to evaluate it. So you see that we need to assume that deaths are okay halfway between birthdays, and the expected present value of the future benefit would be this equation. So you see that once we've assumed that birthdays okay, halfway between birthdays. This is because we're assuming that the benefit is payable immediately on death. So you find this would be just be 1 over would be V to the power 0.5. The increase will not apply in the first year, but will start applying in the second year. So once you've expanded this formula, you see that it would be this, the assurance function. And if you take out now, so that you need to solve this to ensure that, like what I've said in an earlier example, that the increase in the V function should have the same power in the formula for you to be able to evaluate it. So you do it in such a way that you ensure that there's the same power between the increasing function and the discounting function, the V function. So once you take out 1.06 to the power 5, and you also take out the increasing function to ensure that also the increasing function is in the first one, this first item in the equation. You see that this then solves to this. So once you've done that, you see that the constants remain the same, and this would be just effectively be the term assurance function for a life aged 40 with a term of 20 years evaluated at 4%. Yeah, then you add on the pure endowment part, which also evaluates at 4%. And you then get values for these ones in your tables, and also the term assurance function we discussed in terms of how we evaluate it earlier. And once substituting everything, you see that you then get your answer, which is 18,587.06. So this will be now the expected present value of your benefits. So now you need to equate those benefits to the expected present value of premiums using the equivalence principle. So you find that your expected present value of premiums would be P, the temporary annuity due for a life aged X with a duration of 20, valued at 6%. So you see that this annuity to temporary function is in your tables, because 40 and 20 adds up to 60. So you can easily look it up in your tables. And then you solve for P, and P would be 1,549. So in terms of evaluating this kind of question, what you can see here is you need to know that each and every time that you're given the 1.92%, you know your interest rate would be 6%. The resultant would be 4%. Then also in terms of evaluating it, sometimes it's useful to break down the assurance function for you to be able to just intuitively be able to then derive that this is just a term assurance at 4% by just taking out some of the values. So, and also you need to be careful in terms of when they say the benefits are paid. In this case, it's payable immediately on death. So it means that benefits are only accelerated for the death benefit and not the pure endowment part. So usually students make an error on this part, but you need to be sure when you're given an endowment life assurance and it's payable immediately on death, just know that the accelerated bit would be the death benefit, and the pure endowment part would remain as to be just the discount factor. So this is just key when you are answering these types of questions. And also just make sure that you don't lose out the easy marks in terms of not looking up a particular value in the tables correctly. Just ensure you just know where to look up certain values. It will save you a lot of time in the exam. And also just check when you are looking up the value, it is the correct value, so that you can get the overall answer. Even if it's not, there are also method marks that you get for writing things that are correct, even though the answer is not. So I will move on to principles on prospective and retrospective reserves. So here I just want you to recall the principles. We discussed them last time in terms of what they are and the relationship between the two. And I think I also recall saying that you should do a further research on this in terms of when these two are equal, the theory part of it. So you need to just know and appreciate the theory when they are equal and when they are not. So this is just part of your homework, to just look it up and just write a few notes on it. So we're going to attempt this question, just describing how we calculate a net premium reserve for an index-linked annuity. So the question says, an index-linked annuity payable annually in arrears is sold to a 60-year-old male. The first payment is 8,160, and the annuity is assumed to increase at 2% per annum. Calculate the net premium reserve at time 4, assuming the PMA 92C 20 mortality and an interest rate of 6.1% per annum. So you need to appreciate that this is an index-linked annuity. So it increases by 2% per annum. So in questions, just ensure that you highlight the key issues for you to able to appreciate the question and answer it. So this would mean that the first payment, there is no increase. So it would be just 8,168 times 1. But at time 2, the payment will increase, and it would increase by 2%. And then at time 3, it would be compounded by another 2%. So it will be now 8,160 times 1.02 to the power 2 at time 3, and so on. So all these payments are just contingent on the survival of the policyholder, which is the definition we described for an annuity in our earlier lectures. So now we should then assume that this person is alive at time 4. And the annuity payment at time 4 has also just been made. So it would be the end of the year at time 4 where the payment of the annuity payment is been already made. So the expected present value of the future benefits now would be from at the end of time 4 and going into the future. So you find that this then evaluates to, you take out the constant here, which is 8,160. And then at time 4, you see that it will be now considering the benefit that would be payable. At time 4, the benefit has been paid already. So now we're considering the benefit that would be paid at time 5 going into the future. So we now discount the benefit that is payable at time 5 backwards to time 4. That's why we say here 1.02 to the power 4 times VP64, assuming that the person survives. And the person would be 64 at the point of time 4. So you find that also this is the benefit that would be payable at time 6, which is 1.02 to the power 5, and time 7, 1.02 to the power 6, and so on. So you need to discount it back to time 4 and also allowing for survival in these time periods. So that's why this person will have to survive up to 65 and survive for another 2 years and 3 years and so on. So you find that taking out the constant here, it would be 1.02 to the power 3 times the 8,000. And you see that once we take this out and we leave this this in the brackets, you see that this just simplifies to an annuity payable in arrears for a person who's aged 64. So you need to evaluate it at I dash here, and where I dash, where we have discussed in an earlier unit, this would be 1 plus I over 1 plus C minus 1. So here 1 plus I is just 1 plus 0.61% divided by 1 plus 2%, the increase, minus 1, which is 4%. So the 4% would then apply for this annuity payable in arrears for a life aged 64. So this you just look it up from the tables, and you then multiply this and this, and you get your reserve at time 4 in 113 205. So you see that it's just key to be able to evaluate some of these annuity expressions so that you can be able to take out the obvious parts from first principles and then be able to evaluate them. So this is just one example on calculating a net premium prospective reserve for an index-linked annuity. So I don't know if there are any questions before I proceed to the next theory bit on conventional with profit contracts.
No questions from my end.
Andre.
Yes, ma'am.
Yes.
I've got a question, right? When we are doing like actuarial valuations, right? I'm not much familiar with the pension side, but when I was like doing for the general insurance side, right? They are like reserves under premiums, right? Namely like the UPR, that is the end premium reserve. There is also like the premium deficient or the AURR. So is there like a particular name for these premium reserves that we are computing, or they are just called premiums? I don't know.
So this would be the net premium reserve, the prospective net premium reserve.
Okay,
Then,
okay,
yeah. Then if it then includes your expenses and other items, it would be the gross premium reserve.
Oh, okay, okay. Thank you.
Prospective reserve. So just note that there is the prospective approach and also the retrospective approach.
Okay.
Okay, so in the chat section, I'm reading your comments. I'm seeing Andre said, Mates dziriuda kurohwa pabhodhi chirova live. Let's kindly set up a real tutorial though. My intention is for us to just quickly go through the course this week. Then the last week, the next week, the other week is for us to go through the questions where we'll then do a detailed tutorial on some particular questions that might also appear in the exam and also to equip you for the exam.
Thank you, ma'am.
Okay. So yeah, okay. So the videos I'll also be sending. So what I realized is the videos for the first session that we did on Zoom, they are also too large. So I will be liaising with Clet for her to share her email, and I will send a link for the videos where she can then download them and also then share with all of you guys.
Thank you so much for that one.
Okay.
Ma'am,
Yes.
also maybe afford us a 10-minute water break, which is rara to famba.
Yeah, you know what? I just wanted for us to go through the theory bit, EMA conventional with profit contracts. Then after that, tobva tangoita a 10-minute break. Tisati takuita an example.
Oh, all right. Ngatitopinda
It's
mabvunzo
okay.
yapera.
It's okay. So in terms of, I'm just going to give like a brief theory on conventional with profit contracts. So I just encourage you to just have a read and appreciate the theory further of these contracts. So by definition, a conventional whole life or endowment policy, as well as a deferred and immediate annuity, these can be issued on with profit or a without profit basis. So you see that on a without profit basis, both the premiums and benefits under the policy are usually fixed and are guaranteed at the date of issue. So these were the type of contracts that we evaluated their net premiums, reserves, and premiums in our earlier lecture on Thursday. So the conventional with profit contracts, these are now the contracts that we are looking at in terms of evaluating the premiums as well as the reserves here. So these are just generally priced on a prudent basis because you need to also allow for future benefit increases that you would expect in the future. So that when experience proves to be better than the prudent assumptions, you'd expect some surplus to arise, where you then be able to then award a bonus to the benefits of these contracts. So basically, the surplus would just be distributed to policyholders as a way to just increase the benefit. So in terms of how these bonuses can be allocated to policies, you find they can be allocated on as regular bonuses. You would see that the practice in our industry, in the life assurance industry, you see that regular bonuses are awarded. For example, for pensioners, pension increases at the end of the year, which then just increase the pension amount of that pensioner. Or it can be a special or once-off bonus where, for example, you can relate to our situation here in Zimbabwe, where we experienced the currency reforms issue, where we moved from USD to Zimbabwe dollar. There were some special revaluation gains that were awarded to policies at that time, which were just a once-off bonus that was attached to the benefits of individuals. And then the benefit can also be increased by a terminal bonus, where you would say that when the person dies, or when they reach at the end of the term of their policy, for example, for an endowment, they will receive an additional bonus on top of what they've been already receiving. So you find that the terminal bonus rate is usually chosen so as to distribute all the surplus available to the policy. This would be based on asset share. And as a definition, asset share is just the accumulation of premiums at actual investment returns, less expenses and cost of cover. So this is just generally like an equivalent of the retrospective reserve. So what you need to know is the methods in which annual bonuses are added to the benefits. So there's the simple approach, there's the compound approach, there's the super compound approach. So with the simple approach, the rate of bonus each year is just a percentage of the initial basic sum assured under the policy. So you see that in this case, since it's just a simple percentage that is applied on the basic sum assured, the sum assured will increase linearly over the term of the policy. And for the compound, you see that the bonus rate each year is a percentage of the basic sum assured and the bonuses added in the past. And the sum assured increases exponentially over the term of the policy. So this is an example of some of the policies that we were calculating here. Here where we are assuming that the annuity is assumed to increase 2% per annum. This is an example of a compound bonus being awarded under this policy. So you see that the sum assured or the annuity will increase exponentially over the term of the policy. Then for the super compound, you need to know that there are two compound bonus rates that are declared each year. So for the first rate, this one is usually lower and is applied to the basic sum assured. The second rate is then applied to the bonuses added to the policy in the past. And so the first rate applies to the basic sum assured, and the second rate, which is higher, is applied to only the bonuses that have been added to the past. So the sum assured increases exponentially over the term of the policy. But the sum assured, including bonuses, increases more slowly than under the compound allocation in the early years, but faster in the later years. So you see that in the later years, the benefits under a policy that has super compound bonuses, you see that it would have higher benefits than the compound approach as well as the simple approach. The simple approach will have the lowest bonuses when compared to the other two approaches, that is the compound and the super compound approach. So you find that the more that a company defers the distribution of surplus as bonus. When I'm saying this, and what I'm trying to mean here is when the company uses also gives some form of terminal bonus to their policy holders. So you see that if they award a terminal bonus, they won't increase the level of benefits that they are going to give a policy at a particular time. The expected present value of the benefits that they are going to give for a policy at a particular point in time, because the terminal bonus would be given at the end, when the person then is claiming for a benefit. So you see that this defers the distribution of surplus as a bonus, because the guaranteed benefits are lower. So it would mean that the reserves are also low. So this would give a company greater working capital, where it will then allow it to pursue a riskier investment strategy and also achieve greater expected eventual investment returns. So terminal bonus can just be viewed as an extreme example of such deferment, but usually it's used as a mixture of regular or special once-off and terminal bonus. So this is just the theory around conventional with profit contracts. So I will end here. I don't know if there are any questions at this point, so that we can give each other a 15-minute break to stretch, and then we can come back at then we can come back at 15:42.
Good afternoon, ma'am.
Afternoon.
May I ask that in the exam, are we supposed to remember the definitions of the super compound bonuses, the terminal bonuses, or the simple bonuses, or we are supposed to know how to calculate them?
You're supposed to know you're supposed to know the definition of them, and also just be able to calculate them. But calculations, they are really asked though, but the theory side of it.
Or the theory side of it?
But just know also how to just calculate them, because the calculations are not difficult, because you find that the compound approach, we have already done this in the other questions.
Yes.
Yes. So if for the super compound, I would say just know how to just calculate it from first principles. The simple approach is also simple. So you see that from the examples that I'm giving you, you'll be able to see how these are calculated, but just know also the theory, the definitions, they are important.
All right. Thank you, ma'am.
Okay. So if there are no questions, I'm seeing Andre. You have a question?
Yes, ma'am. Afternoon. I'd like to ask, will the actuarial tables be availed for our exam?
I'm assuming they should be availed.
Maybe what happened in the other exam which was written last year?
Oh, it didn't have the table.
Oh, I can ask it time. Not print.
No, but the tables are available at the statistics office. The last time that we wrote financial maths, we were given actual tables. Remember, we missed the financial maths in part 2. They're available.
Yeah, I assumed they are available. It would be difficult to actually write the course without them.
I don't know about the ones we can use for practicing, but I hope we can use the soft copies. But as for the hard copies, I think they are available.
Yeah, the soft copies I saw someone sharing on the WhatsApp platform. So they are just the same as the hard copies. So you see that for those who would want to attempt CM1 for April 2023, given that you did financial mathematics in part 2 and you're doing the contingency course in your part 4, part 1, you see that you'll be given also the soft copy tables, because the exams are now online.
Yeah, thank you.
Okay, so I think let's break, and everyone comes at 15:46. So 15:46 will start. We can start So we'll start by an example. 20-year with profits endowment with a basic sum assured of 15,000 was issued to a man aged 45 exact at entry. The policy has been in force for 7 years. The policy is subject to simple reversionary bonuses that vest at the start of each year. The death benefits are paid at the end of the policy year of death. In addition, a terminal bonus equal to 25% of the sum assured plus existing bonus is payable on death or maturity claim. Simple bonuses were declared at the rate of 4% for the first year of the policy and 3.75% per annum thereafter. The company expects to pay future bonuses at a rate of 3% per annum from now on. Calculate the net premium reserve for this policy as at the present time. Assume a M92 ultimate mortality and 4% interest. So since we are asked to calculate the net premium reserve for this policy, as you can see from the question, we were not given the net premium. So what this means then is that we need to derive the value for the net premium for this endowment policy. So we first calculate the net premium, which would be calculated based on the basic sum assured only. So this is, if you solve for P, it will then give you 15,000 and the endowment assurance function divided by the annuity due temporary annuity function. So these functions you can easily get them from the tables because 45 and 20 adds up to 65. So once you've gotten them, the premium would be 511.59. So what the question then is asking is the reserve, net premium reserve for this policy at the present time. So what you need to do is to calculate the past reversionary bonuses, but this would exclude all future reversionary and terminal bonuses. So the past reversionary bonuses would be equal to 15,000 times 0.04, which is the bonus, simple bonus at the first year, and then the 3.75% is for the other 6 years. Then the total bonuses would be 3,975. So you need to take note that the net premium reserve here will only include past reversionary bonuses, because at a point in time you see that you'll be reserving for what you're expecting to pay out. And once the bonuses have been attached to the policy, they've increased the sum assured, they cannot be taken away. So let's say if the person dies after time 7 and dies in between year 7 and 8, you'll see that the person will get the sum assured of 15,000 plus the 3,900. So that's why we only include the past reversionary bonuses and exclude all future reversionary and terminal bonuses. So you see now that when you now want to calculate the net premium reserve, the prospective reserve at time 7, you then say the benefit 15,000 plus the past reversionary benefits, which is 3,975, times the endowment function, where now at time 7 the person would be now aged 52 and would have a duration of 13 years left. Then in terms of the premium, we've calculated the net premium here, which is 511.59. Then you then multiply it by the temporary annuity due, where the premium payments will be the same duration as the assurance function. Will only be, the person will only pay for 13 remaining years, subject to them being alive at this point. So this assurance function in this temporary annuity due, you can easily look them up in the tables because they add up to 65. And once you've included them, this would be your answer. So we are now going to just look at the brief theory for the accumulating with profits policies. So before we took a break, we discussed conventional with profit policies, and now we're just going to discuss accumulating with profit policies. So this is just a basic benefit where an accumulating fund of premiums has discretionary interest rates. So just take it as like a bank account where you deposit your money and you get interest for the period that you have invested in your money for. So in terms of the accumulation, it will just basically follow this recursive relation where the fund at FT will be equal to FT minus 1, the fund value at the start of year T plus P. P would be the premium that the person would have paid in the year between T minus 1 and T, and then G would be the guaranteed annual interest that is given. So it would be 1 plus G, would be increased by 1 plus G. Then BT is the annual bonus interest for year T. So the fund value at the start of the year, you would then be added on with premiums that are payable that year, and this would be increased by the guaranteed annual interest as well as the bonus annual interest for the year. But we also need to take into account that the fund value would also need to also cater for any charges that were taken from the charges to administer the fund, like administration charges, management fund charges. So it operates in a similar way to a unit-linked contract. So on death or survival, the benefit can either be increased by a terminal bonus, and accumulating with profit contracts can be unitized or can be non-unitized. So for the unitized with profit contract, the guaranteed interest is factored into the unit price, and the bonus interest can be factored into the unit price also. So this can be just be done by allocated by creating new units, and policies may also include a guaranteed minimum benefit, and the unitized with profit policy is usually subject to explicit charges to cover expenses and any additional death benefit cost, like I had indicated earlier, to say that over and above accumulating the fund value at the start of the year, you'd also need to take out any charges that would be required to meet expenses and the additional death benefit cost if it's guaranteed. So here we're going to look at an exam style question. So the question says, on 1 May 1998, a life insurance company issued a conventional whole life with profit policy to a life then aged exactly 45. The basic sum assured was 50,000. The sum assured and attaching bonuses are payable 3 months after the death of the policy holder. Level premiums are payable in advance for the whole of life. The company calculated the premium on the following basis. Show that the monthly premium is 85.65 pounds. So the mortality is MA92 select. Interest rate is 6%. Bonus loading is compound 1.9231%. Initial expenses are 300 pounds. Renewal is 5% of each premium, excluding the first. And then termination. This one is payable at the same time as the death benefit. So for you to be able to calculate the monthly premium, so this will now be the gross premium because it includes expenses. So earlier we were just calculating the net premium, but here it's now the gross premium that a life will actually pay to the life office to get a policy. So it's just the same thing in terms of calculating this. You first calculate the expected present value of benefits plus the expected present value of expenses, which will equal to the expected present value of premiums. So here it says that the sum assured and attaching bonuses are payable 3 months after the death of the policy holder. So this means that this policy the benefit is paid 3 months after the death of the policy holder. And so we will assume here that this is a whole life assurance policy that is payable immediately on death, and we have to make an assumption that this would happen midway within the year, and then we'll then add on the 3 months to the timeline to get the actual time of payment of the death benefits. So also we need to note that there are level monthly premiums payable in advance for the whole of life. So premiums are payable for the whole of life for the individual. So we go to the solution. So we first calculate the expected present value of premiums. So these are payable. Here it says level monthly premiums. Payable in advance for whole of life. So this would be 12 times P, which would be the annual premium, because P would be the monthly premium. So you want this to convert it to an annual premium. So it would be 12P times the annuity due for a select life aged 45 with the subject on the top 12. So here, if you recall this annuity due function payable monthly, we can convert it using the formula where the annuity payable monthly can be made equivalent to the annuity due payable annually in advance minus M minus 1 over 2M. So M would be the number of times that the annuity would be payable. So you find that this is why this simplifies to the annuity due for a select life aged 45 minus 11 over 24. So this you can easily look it up in the tables, and you see that this will then solve to 172.76p. So as I said that since we have to assume that deaths occur halfway through each year of age, so also we have to assume that the benefits are payable 3 months after death. So we need to write an equation of value for these benefits. So you see that we take out the constant 50,000, and then we then put in the values. So if we add another 3 months, because we are assuming that it occurs halfway through each year of age. So here it would have been v to the power 0.5, but we're adding another 3 months on top. That's why it's 9 over 12. And the probability of the person dying within the first year for a select life aged 45. So then we then add, and this benefit is increased because there is a compound bonus loading vesting at the end of each policy year. So it will not apply for the first year, but it will apply for the second year, as we have seen in our other earlier examples. Then you add the other 3 months to get v to the power 1, 9 over 12. Then the probability of a select life surviving for a year and then dying the next year. Then this then just carries on for the third year, fourth year, and so on. So as I said earlier, that we need to just make sure that the power on the V term here, the V function, is the same as the term that would be increasing the assurance benefit. So you find that we have to ensure that it would be like this, having the same power. To the power 1, to the power 2, to the power 3, and so on. So you see that if we multiply everything inside the brackets by this and divide the 50,000 by this, we will be able to achieve what we want in terms of just making the increasing part and the power on the V term is the same. So you see that this then simplifies to this here. And you see that you need to now, it will be now the V's, it will be now a different interest here, where we've said that if you want to get J, you'd have to then say J is equal to 1 plus I over 1 plus B, which is 1.92%. So you see that you get then your 4% from that formula. So once you've done that, this is simplified, and you see that this one, this term here is similar to this term from first principles. So this A whole life assurance function for select life aged 45, it will now be calculated at 4%. So this you can easily look it up from your tables, and you can also be able to simply also evaluate this function. So once you've looked up this assurance function from the tables and you simplify this, you find that the expected present value of benefits is equal to 13,729 and 84 cents. So you see that this is now your expected present value of benefits. Now to your expenses. Here we've been told that our initial expenses are 300, and the renewal expenses are 5% of each premium, excluding the first year. So, and also the 200 pounds payable would be the termination expenses at the same time as the death benefit. So these termination expenses would only be payable when the person dies, in the event the person dies. So you see that the expected present value of the expenses, it would be the initial expenses 300 plus 0.5 times the premium, the annual premium, times the whole life annuity due function for a select life aged 45. But you need to subtract a 1 here to remove, because this says that the renewal expenses exclude the first premium, so you have to remove the first premium. So that's why we're saying 1/12 here. So if you see it, you see that if we multiply 12p times 1/12, you see we have removed the first premium p. Yeah, that's how it will solve too. Then you add on the 200 termination expenses, and since they are payable on the person dying this would be this one, immediately on death when the person dies at 6%. So since the benefit is paid 3 months earlier to be paid at the same time, so you need to factor in the v to the power 3 1/12 to bring it backwards. So once you have so written this equation here, you see that you need to solve for each function here. This one, the payable immediately, this one, but this one we have the answer because we did it when we're calculating the expected present value of the premiums. So you see that this one, we use this result here, and then you multiply by this one to bring it to forward, and then you have this as your answer. So once you've substituted everything now in your expected present value of expenses, you then have this as your answer. Then from the equation of value, you need to add the expected present value of expenses plus the expected present value of benefits. And then you equate them to the expected present value of premiums. Then for solving for P, you then get this answer. So you see that it's very key for you to underline key aspects in the question so that you will also be able to exclude some of these things. So when the renewal expenses is said to exclude the first year, you'd have to subtract that one from the annuity factor. And also you need to also be able to allow for the bonuses compounding for the benefit, and also know that the termination benefit will only be payable at the same time as the death benefit. So the present value of this would be calculated using the assurance function, because it will only be payable at death of the person. So you need to know that this assurance function for the termination expenses will be calculated at 6%. But for the benefits for the individual, since they include this bonus, the assurance function will be evaluated at 4%. See here. So when you're showing your working, you need to be clear how you are evaluating your assurance functions at which percentage, as well as here you see that we have evaluated this assurance function at 6%. So this really needs to be clear for questions where there is some compounding of some sort for the benefit side. So for the next question, before I move on to the next question, are there any questions?
Mine is a question. I just want to understand. We normally, when you want to calculate the immediate payment, we discount to the power 0.5. So so I noted that you said you multiply. We use 9/12. And then the next one we add a year after. So is it that we just need, we will calculate it from 0.5, then we add 3 months from there, just to take note of how you're calculating?
Yes, so that's basically what's happening here, because we have assumed that the benefits are payable immediately on death. So we have like assumed that the benefits are paid at the middle, between the age of the person, in the middle of the year. So we know that the assurance benefit would be paid 3 months after the death of the policyholder. So when we're now discounting, we need to allow for that 3 months. So that's why we are now saying 6/12 plus 3 months. Then in the second year, it would be also 1 and 6/12. So we need to add the 3 months again.
All right.
Yes, that's what's happening.
All right. Thank you so much. Thank you so much.
Okay. So I'm going to move on to the next part.
That's fine.
The next part then now says that the company holds gross premium retrospective reserves for the policy calculated on the following basis. So the mortality is still the same, MA 92 select. The interest rate is 4%. You need to take note of this because it's different from the premium basis. And past bonuses were 4% compound, vesting at the end of each year. Then expenses, initial expenses, we were given to them to be $300, pounds, then renewal, £5 at the start of each month, excluding the first month. Then termination, £100 payable at the same time as the death benefit. So what here they want us to do is calculate the reserve for the policy on 30 April 2005. So you see the policy commenced on 1 May 1998. So from 1 May 1998 to 2005. So we need to calculate the retrospective reserve at the end of the 7th year. So we need to calculate the retrospective gross premium reserve at time 7. So we need to start with the formula. So it's the same formula that we did for the net premiums, but it now just includes expenses on the EPV of benefits and expenses. So the retrospective reserve at the end of year 7 is the expected present value of past premiums and minus the expected present value of past benefits and expenses times D45 select and D52 select. This is just the discounting factor which has been inverted, and we're now accumulating it. So what we are doing here in calculating the retrospective reserve, we are bringing back the premiums at time 0. And we are bringing back again the past benefits and expenses at time 0. And then we are then accumulating these benefits to time 7 so as to get the retrospective gross premium reserve. And also allowing for surviving of the individual at time 7. So that's why we are using this accumulating, now the accumulating factor. But if it was the other way around to say D52 over D45 selected would be the discounting factor. So we are basically bringing these items, the past premiums and past benefits and expenses paid, to time 0. We are discounting them back to time 0 and then accumulating them to time 7 to get the retrospective reserve. So that's what we'll be using for us to determine this reserve. So in terms of the expected present value of past premiums, you need to say 12 times the premium that we calculated earlier, which is 85.625, times the temporal annuity due payable for 7 years. So this is basically just discounting the annual premiums that have been paid for the first 7 years. So since the premiums are payable monthly, we have this 12 on top of the A here. So this will need to be simplified again. And we know that we can easily simplify it with the formulas that we've used before. Then the past expenses, we now need to calculate the expected present value of past expenses. So the past expenses, we need to input them as they are. To say this would be 300 plus 12 times 5, because 5 would be payable at the start of each month. Then this would be discounting the renewal expenses paid at the start of each month. But we have to know that we have to subtract the first renewal premium, because the renewal premium start at the second month, not the first month, because we would have paid initial expenses. That's why, simplifying it, you'd now say 300 minus the 5, then you get the 295 here. Then for the termination expenses, you'd now say, in a similar way, we have simplified it. It's payable when the person is died within that period. So the discounting factor will be the term assurance function, and we need to allow for the 3 months because it's paid 3 months after the person has died. So it needs to be accumulated as well. So this would be the equation for the expected present value of expenses.
Ma'am, that's the point where I'm being confused. Why are we multiplying by 3 over 12? Isn't it supposed to be 9 over 12? I mean 6 over 12 plus 3 over 12. Why are we multiplying?
No, yeah, because it's because we are saying that the benefit is, like, when we simplified it here.
Yes.
because here we were saying that when we did this evaluating, we discounted by the 3 here, isn't it? Because it's payable 3 months earlier. But the
Correct.
yeah, so you've gotten it, isn't it? Hello?
Yeah, thank you so much. This question. Sorry.
So this will then simplify to this too. So that's why we are doing the same here for the expenses. Where was I? Here. So it will be the same result as this one.
What's happening to my network?
So for the past benefits,
Uh.
the expected present value of the past benefits now would be as before. We've done before up to the 7 years, v to the power 9 over 12, the same as before, but up to the 7th year. And if we take out v to the power 9 over 12, this just basically simplifies to Q 45, because this is valued, the V is valued at 4%. So once we've taken out the 9 over 12, you find that this would be 0.04 V, and V is 1 over 1.04. So it would then cancel out everything. Then it would be now become Q45 plus the person aged 45 surviving for a year and then dying the next year and so on up to the 7th year. So once you have done that, this expression here simplifies to this, because that's how you'll be calculating. If you simplify it in simplified terms, if you want to calculate QX45, it will be 1 minus P45, and the next one it will be P45 minus this. I think we did this in our earlier lecture. And once you've taken off the brackets, you see some of these will cancel out. For example, here, here will cancel out, and so on. So you find that we'll be left with only this term. So it will be 1 minus
Hello, ma'am. May you please unmute yourself?
Hello. Sorry for that. I was talking to myself. I didn't realize I muted my mic. So where did I last explain? Okay, so yeah. So I was just saying that from this equation, since we now have the expected present value of past premiums and the expected present value of past benefits and expenses, you then substitute in this equation and then you multiply by this accumulating factor. So you see that the retrospective reserve at time 7 would be the expected present value of premiums minus that of benefits and expenses, and you then accumulate it.
It happened again, ma'am.
Sorry, I don't know why it's muting. Maybe it's when I'm clicking my mouse, it's automatically then muting my mic. Okay, so we then need to evaluate this the annuity function and this one as well using whole life assurance functions. So in the D functions, you can look them up in the tables. So you see here, we've evaluated it using the formulas that we know. And then the D's, we've just looked them up in the tables. And AE, the temporary annuity due for a life aged 45 with a duration of 7 years, you are evaluated using the whole life annuity due functions. Then you get your answer in this, then simplifies to this, as well as the term assurance functions. We use the whole life functions, and Q7 45, it will be just 1 minus 7p 45, and you can evaluate it using the L functions in the tables. So you see that once you've included everything in here, the retrospective reserve would be 6,571.91. So this is just basically how you calculate your retrospective reserve. So it's just one example. So I'll just talk through the gross premiums and reserves. So just you see that for gross premium reserving, for determining gross premiums and net premiums, the difference is largely due to the inclusion of expenses, and also at times the profit margin can be explicitly stated. So you'll find that the gross premiums would be calculated as the expected present value of benefits plus the expected present value of expenses, which would be equal to the expected present value of premiums. This can also be just modified to also include profit, where you'd also need to add in the expected present value of profit to make it equivalent to the expected present value of premiums. So in terms of the expenses, you just need to know that expenses will be incurred by the life company, and the costs will need to be met. So usually for the assumptions for expenses are determined when an investigation is done for expenses. So usually the expenses are broken down into overheads and direct expenses, and they can be apportioned either on a per policy basis or directly to the expenses where they relate to. So these per policy expenses can be further split into initial, renewal expenses, and termination expenses. So I think you also saw that in the example that we did just now, where the expenses were broken down into initial, renewal, and termination expenses. So these will need to be allowed for when you are calculating your premium. And also at times in questions, they might say that expenses, for example, the renewal expenses increase with inflation. So you'd need to allow for inflation at times when you are calculating the expected present value of these renewal expenses, sometimes in a given question. So then in terms of the gross premium reserves, the prospective reserves, you see that this would be just the expected present value of future benefits plus the expected present value of future expenses minus the expected present value of future premiums. So you find that this is just how the prospective reserves would be calculated. And the difference between the net and the prospective reserves is largely due to the net reserves. Prospective reserves don't include future expenses. It will be just the expected present value of future benefits minus the expected present value of future premiums. Then in terms of gross retrospective reserves, I think we did this in the earlier example where we just say the accumulated value of the expected present value of premiums minus the past benefits and expenses. So this is basically how these are determined. So this is you should just generally know how to use these formulas for you to be able to apply your knowledge to solve particular questions. So there is also you need to know when the equality of these reserves are equal. So for a given equality of basis used to calculate the premiums and the reserves, the prospective and retrospective reserves of any policy at any given time t will be equal. So you need to know the specific conditions on when these two positions are equal. And if you want to read further in terms of the derivation of these bases when they are equal, you can read through the course books or course notes that I previously shared. And the recursive formula for the reserves at successive values at time t are related by this equation. So this would be V T, the start of the year t, or at the start of the year t plus 1 to be the end one. Then you add in the gross premiums, then you subtract the renewal expenses, and you then accumulate it by 1 plus I so that it reaches the end of the year t plus 1. Then you subtract the probability of the person dying within that year t and t plus 1. And you factor in the assurance benefit as well as the termination expenses. So this would be equal to the probability of a life-aged X plus T surviving for a year times the reserve at T plus 1 at the end of the year of T plus 1. So in terms of calculating the profit for the year between policy durations, you see that you would just need to subtract the reserves, this item here minus this. So here the primed functions represent the actual experience over the year. So you would need to calculate the V functions, the adding the renewal expenses, the interest rate, the Q function, the termination expenses, using the actual experience over the year. And usually this is stated in the question, where they give you the premium basis as well as the actual experience over the year, so that you calculate the profit for the policy between the policy durations T and T+1. So G is the gross premium, E are the renewal expenses, F is the claim expenses, and S is the sum assured. So we're going to start with an example, a simple example. And the example says a life aged exactly 40 purchases a special single premium deferred annuity. The annuity payments are to commence at age 60 and are payable monthly in advance for life. The amount of the first monthly payment is to be 1,000, but once in payment, the amount is to increase in line with the rate of inflation. There are no death benefits payable in the event of death during the deferred period. Show that the single premium is 54,543. And basis, we assume AM92 select before age 60 and PAM92C20 after age 60. Then the interest is 6% per annum, inflation 1.923%, per annum. Then the initial expenses are 500 pounds, and the claim is 1% of each annuity payment. So I think we've done quite a number of questions on this in terms of calculating the single premium. So I will allow people to attempt this. First part, I'll give you about 7 minutes, then we can discuss the solution. Hello? 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 Hello?
Hello, ma'am.
Yes?
We're still working on it.
Saka yoita hayo homework. Yoita homework handiti. All right. So I'm going to send manotaya just now. Then also muchaona kuti pane two my examples futi. Andinoencourage kuti munhu wese attempt. Then I understand kuti class you were more than 100. Umeno muri vangani?
Around 150, ma'am.
160. So ndandichida kukupai group assignment. So ndandichiti mumagroups acho since muri kana 160, then each group inenge ine vanhu 20.
All right.
Okay, that will be fair.
Okay, no problem, ma'am.
Yeah? Okay. So I will send the group assignment tomorrow, and then there will be another assignment yechi2 inenge ichiitwa as individuals. I think I'll send it tambo cover zvimwe this week. Then next week a short test pazvinhu zvatiri tazodzidza zvese.
Oh, okay. Okay, ma'am.
Then also so I said manotsi aya ndichashare, then videos ndichashare futi ndapiwa email address naclate yake so that I share the link yemavideos because akakurisa haasendeke via email or anything, then ndotomupa link kuti azodownload. So let's call it a day.
But
So
test apa kuanziri basa here rekumaka apo madii tangoita iri assignment.
kuti oita ese ari maassignments.
Ya akangoita ese ari maassignments zvokurerukirewo pakumaka.
Hai, but makazoita 160 muklasi.
Ipapo handikwanisi kupapindura mimo.
Wacho wainyanya kugona chikoro.
Zveshuwa so mheno it's either kuti mamwe two ndinenge ndomaita magroup assignments then imwe yoita individual I think. Ndichaona ndoita
That's fine. That's fine.
Because magroup assignments I think anondirerutsa hangu basa, so munenge muchiita in groups of 20. So I think nichangolayasa na-class rep so that anozondipa mazita emunhu wese kuti pasazoshaya anenge asipo the register list yacho yema-names eclass.
Okay, ma'am. Thank you very much.
Right. So
Ma'am? Okay, sorry, but between like the prospective method and the retrospective method in computing the reserves for long-term insurance coverages, right? Let's say in the event that I'm not given like the approach to use, right? Am I free like to pick between the two, the one that is easy for me?
Yeah, you can pick kana pasina explicitly pasina kuudzwa kunzi ita chakati, but ma-questions awo anowanzonge ari direct kuti unofanirwa kutocalculata prospective reserve kana kuti unocalculata retrospective reserve. They are not usually vague like that.
Okay, thank you on that.
But kana question hayo isiri clear, either approach is acceptable.
Okay, that is fine.
So I think let's call it a day, and I encourage everyone to attempt my questions and share, because these questions are just a reflection of what will appear in the exam. So time questions and also practice also other questions as well. And also read through the course to just familiarize yourself with notation. And my questions acho zvinobatsira given short period yamunayo yekunyora iyi hakana kukrema chaiko, because kana usingazivi kuti unosolva sei imwe assurance function iri mune specific notation usingazive conversion yacho zvinogona kunetsa. So just continue perusing through the notes and familiarize yourself and practice. Unoona kuti the more you practice, the more zvinobva zvabatika. So I wish you all the best till we meet again. Bye-bye.
Okay,
coming this week?
Yes, I'm coming on Wednesday.
All right.
So tomorrow no lecture?
No lecture. Mune assignment. A group.
Thank you very much.
Okay.
Good day.
Okay, bye-bye.